Hi, very good evening, and good evening to Akash Saxena. Yes, Akash, you have sent me that message, but I was a little bit occupied today. I'm making a video on topology, which was not okay in the last time. So I haven't been able to look into that equation, but I will surely look into it by tomorrow and give you a answer to that. Yes, good evening, Rahat, and welcome to this second, I would say, discussion on critical thinking. Now, I think Vishal or maybe Rahat, I really don't remember. You asked me a question regarding what is called logical fallacy. So I was not being able to answer regarding that. So I would first like to answer the concept of logical fallacy, which was asked, and I was not prepared with that. So logical fallacy, this is a kind of a definition, which is logical fallacy. So logical fallacy is an argument that may sound convincing or true, but is actually flawed. That means logical fallacy is a leaps of logic that leads us to unsupported conclusion. Yeah, Rudrasi, namaskar. And thank you everyone for making yesterday's podcast very successful with Professor Arun. So people may commit a logical fallacy unintentionally due to poor reasoning or intentionally in order to manipulate others. So I will just show you some one example of logical fallacy. So here you see the first premise says that Peter Parker is a Spider-Man. We know that. The second premise says that citizens of New York know that Spider-Man saved their city. I'm just that is fine. Now, the conclusion it tells is that citizens of New York know that Peter Parker saved their city. Now, this is wrong because the citizens of New York know that Spider Man has saved the city, but they don't know that the name of Spider Man is Peter Parker. So, the conclusion is thereby false, and this is the logical fallacy that citizens of New York know that Peter Parker saved their city. So this is, yeah, Karan. I think Karan was the one who asked me the question of what is a logical fallacy. So here you see this is something which is called a logical fallacy. Now, I mean to say, the New Yorker don't have any idea about who is Peter Parker. Then how can the citizens know that it was Peter Parker who saved the city? This is one logical fallacy. Uh, the second one is that my father smoked 4 packs of cigarettes a day from age 14 and lived until the age of 95. So smoking really cannot be that bad for you. So this is also logical fallacy because there is insufficient evidence except his father to draw a conclusion that smoking is not that bad. So I hope this makes it clear that why we get into logical fallacy, and most importantly, this type of logical fallacy we should consider while making a kind of a critical thinking, and not only that, when we are writing a proof-based mathematical system, this type of things should be taken into account. Okay, so here is a formula which you might take into critical thinking. I mean to say, you can just think that anything which is coming into your mind, you can consider this to be a critical thinking, a formula. We call it when, where, why, how, who, which, whose, whom, what. That means if you're getting a kind of a question, for example, even if I take a simple example, for example, f equals to ma, then when this equation has happened, where has it happened, why it has happened, how the equation has been derived, who derived the equation, which are all the other implications, whose, whom, and what. All the way these equations or these questions won't be applicable, but when, where, why, whom, whose, whom, these type of questions, if you can take into consideration, I think that you can get into critical thinking. So logical fallacies should be answered. Let me go back to the slide where we actually started about. So this was the kind of a logical fallacy that we talked about, that x equals to 5, y equals to 2. So x plus 5 equals x plus y equals to 7. That means in every occasion, it would be 7. So that is called the affirming the consequent. Also, what we find over here is that we need to make generalization. Now, this is also a part of the critical thinking. What do I mean by generalization? That we need to be very clear about the scope. For example, the generalization of Pythagorean theorem, if we want to generalize the Pythagorean theorem into several other theorems, generalization of the Fibonacci sequence, commutative property of addition, associative property of addition, these are actually, a kind of a generalization. So by understanding these generalization, we can better understand the underlying mathematical principles and apply them to a wider range of problems. Remember that whenever we are trying to find out a mathematical equation or a mathematical formula, or those who wants to become a theoretical physicist, generalization is a very important factor. Any mathematical statement, any theoretical physics statement, any kind of a theorem that you are developing, just as I told you that if this is equals to 5 and that is equals to 2, then not necessarily that all the answers will be that same, or all the subtraction would be a prime number. So when we are taking a kind of a, when we are going for an invention, when we are going to discover something, either a formula or something, first of all, the basic thing is that we have to understand the logical fallacies. There should not be anything which is, I would say, circular in nature, that if we start with a formula, we are again getting back. No, it should be unique, and it should be applicable to everywhere. We talked a lot about generalization, from Galileo's law to Newton's law, from Newton's law to Maxwell's law, from Maxwell's to relativistic equations, and so on. So the entire history of physics, and the entire history of, I would say, physics primarily, is concerned with a lot and lot of generalization. I have already made a video called From Classical Mechanics to Modern Physics, where I have shown how the formula have actually generalized from one place to another. And as I told, that necessity is the mother of invention. So all this formula, all these things were required in order to generalize. So critical thinking obviously is something which we called critic, means you are going to make a judgment, yes or no. You're going to be unbiased. You have to be very skeptical. You have to get a lot of data, and you need to generalize things so that it is applicable to different areas. So we also see that in order to testing a hypothesis, if the speed of, for example, if the speed of light is constant, then the time it takes for light to travel from one point to another should be the same regardless of the direction of travel. I mean to say, this is the hypothesis. So the critical thinking shows that what is the experiment and what are the results. So as I told you that, this type of a hypothesis was actually taken up by Michelson-Morley, that there is no ether, which was further taken up by Albert Einstein, that if the speed of light is constant, then he formed the inertial frame of reference and the special theory of relativity. That is also a classic example of critical thinking, that hypothesis, the testing has been done, and how it can be used and generalized into various other areas. Okay, success boys. Okay, fine. I don't have a problem in math and physics, but I have a problem, or I can remember what physics theory I have read. Please give me tips. Well, I still don't get your point. You don't remember what physics theory you have read. That means what? I mean, the physics theory is based on mathematics. Do you not understand the physics theory, or you forget the formulas, or what it is? Please let me know in the comment box so that I can, in the chat. I don't have a problem in math or physics. Okay, that means you understand math very well, but have problem or I can't remember what physics theory I have read. I mean to say, I think that what you are asking is that you can understand the underlying mathematical calculation, but you cannot understand that what that mathematics actually shows. So, is it? Am I right onto the point? You can let me know. So, if it is so, then I can further elaborate on why you are unable to understand. Please let me know in the chat box. I will wait and go ahead with the other part. So here you see critical thinking is also associated with mathematical modeling. I've given an example. Say, for example, a company wants to determine, yes, okay, fine. So now the thing is that what I would like to say, I will come to this. Let me answer to this question. This is a very important question. Now, can you just tell me your name? I don't want to call you success boys. But anyway, So the thing is that means what is happening is that you are actually learning the physics theory or the underlying whatever is there in physics without knowing the practical application. Now, if I say, for example, if I give you an example, 5 plus 5 equals to 10, that means what you know, that you know the mathematics 5 and 5 equals to 10. But the physics behind 5 plus 5 is what? That if you take 5 apples over here and 5 apples over there, that would lead to a bigger basket which will contain 10 more apples. Am I right, success boys? So that means that the physical implication of mathematics is not being known. And this is exactly the purpose of my videos in my channel. You see, I never explain the mathematics at first. I think it will be a very good video on topology. So first thing that you need to know, success boys, is that what is the underlying meaning of that? Physically, what is taking place? Is it an apple is falling, or a bird is flying, or it is a rocket which is going up? So you need to understand the physics for first. So for that, success boys, what I would recommend you is that before going into the mathematics, go for an intuitive understanding of physics. You can even contact me. I will try to explain whatever the problems that you're facing. I have no practical knowledge or practical or experiment. No, you don't really have to do the experiments. Okay, but what you need to do is that you need to visualize things very strongly. How many of us do have an experimental lab that we can go and experiment? But you need to intuitively visualize, intuitively understand. So things like linear algebra, things like abstract algebra, group theory, there are a lot of mathematics I think you have gone through. Now, the problem that you're facing is that you don't have the visualization that how these things actually physically on table, chair, on this entire surface of Earth, how it takes place. So you let me know what I would recommend you for that. You need to go to an intuitive understanding. Try to understand what is the easy meaning of that. I mean to say, not all mathematical equations will give you that this is an apple, that is an orange. Are you getting my point? Now, if you say what is a matrix, what is the determinant of a matrix, you can understand what is the determinant of matrix, but you cannot say that, okay, this is actually physically determinant of a matrix. Okay, you have no right guide for physics, you can contact me. I would like to help you as much as I can. But what I'm trying to tell you is that it is not a question of getting a guide. It is that you need to improve your abstract thinking, critical thinking, visualization. Are you getting me? So the thing is that now if you say, sir, show me practically with matchsticks or a apple and guava, that how will I calculate and what is the determinant of a matrix? I'm sorry, I won't be able to do that, because mathematics itself is an abstract concept, and all of abstract concepts cannot be shown over a table, on a chair, on a cup, or something like that. Are you getting me? So what you need to do is that before going into the mathematics, try to understand what is the physics behind it. Search out in Google, search out to Quora, search out in different type of artificial intelligence tools also. But be aware, AI gives a lot of false notions. What is the physics behind it? What is practically happening? Improve your abstract thinking, improve the way things happen, and close your eyes. I would say meditate, because meditation is very important nowadays. People hardly meditate. During our days at Ramakrishna Mission, etc., we used to do a lot of meditation. So do meditate a lot of things will come to your eyes. Go Another thing I would give you a tip, this I think would be useful. Whenever you are trying to find out a concept which you are unable to know physically, I mean to say physics, for example, I will take you a concept, what is a manifold? Okay, so physically you want to see what is a manifold. Best thing I would say is that go to Google, type out what is manifold, and go directly to the images section. I hope I can make it clear. Go directly to the images section, because the moment you type out a concept of physics, if you go to images, the first thing is that you need to see the images. If you see the images, then you come back to the mathematics, things will be clear. I would say then wherever you're doing any kind of a mathematical problems or any kind of a physics problem, instead of going into the mathematics, type out the concept, go to Google, go to images and type it out and see what that image show. Whenever you get an image right in your brain, then when you do the mathematics, your brain will subconsciously constantly try to map what you learn in the mathematics and what you have saw in the images. I hope I can make myself clear. I can improve my math by sitting and doing, but what for physics? What is the best method for master physics from at beginning to advanced? As I told you, that if you really know the mathematics very well, you can easily understand physics, because each of them are related, just like fitting in hand in glove. So all you need to do is that if you're unable to understand the concept of physics, first go to the images section, look into the images, look into the animations that it provides, then go back to the mathematics. Even how do you visualize time? Okay, for example, now in order to visualize time, the best thing is that you have to see to the clock. Now, if you say that I want to, imagine a four-dimensional time, etc., but a clock or your wristwatch or a clock will give you the concept of a time. Then from that, yeah, Ashirwad, very good evening. Then from that concept of a time, once you understand how the clockwork moves or what is the concept of a basic time, then from there you can move ahead. I mean to say, Rudra, I don't think there is any problem in visualizing time. Now, if I say, for example, time as a complex space or as a complex number, even there, I would succeed. Why? Because I have already got the concept of time. I can see the clockwork. I can see the seconds hand moving. I can see the hours hands moving. I will just put it in the complex plane. And then also the basic concept of time will be the same. But in a complex space, there are many other mathematical things which will approach. So success boys, what I would request you to do is that first of all, it is very easy. Go to images section, see the animation, see the images, then go back to the mathematics. If you know the mathematics, even when you're doing the mathematics, brain will constantly register with the images that you have shown. I understand this is a problem with the conventional learning, because when you're going into class, the first thing that your teacher tries to do is to solve the problems in mathematics. And that is why I don't try to do with my students. I never tell them that do the mathematics, but rather first go into the motivation, visualization, intuition approach. If you go to my videos on topology, 3 to 4 classes, we have only learned about intuition. I tried to show them over clay, which was not done, but I'm making another video which will give you a very clear approach. And you're never going to face any problem in order to imagine abstract spaces, homeomorphism, and topology. I can promise on that. Right on my channel, I'm giving you a word. How to improve my visualization, imagination, creativity required for systems to have fun with it. I don't know how to enjoy physics and have fun with it. You start reading books. I mean to say, that is the thing that creates a lot of fun. Physics itself is a matter of fun. So what I told you is, again, is a very practical approach. Go for a concept, anything that you want to learn in physics. Try to find out the images, try to find out the imagination. Go to blogs and try to read what it is all about. Again, an overall approach. Get a kind of an overview. You will get about general relativity, special relativity, differential geometry, everything in my videos. I have given a very intuitive and overall approach. Then go into the mathematics. I think things will be clear. Does reading popular science books helps to be more intuitive, Karan? Yes, it does, but it comes with a cost, because popular books gives you something, a very romantic and a wrong idea that you should be care about. I have already made a video on what is called popular misconceptions in quantum physics. Yesterday I made a shorts. So you have to balance in between what you are reading and what is the idea, and then you have to find out a kind of a I would say intuitive approach. But intuitive approach should not be mixed with a highly romanticized and a wrong approach. Intuitive approach is good, but not with a wrong approach. What is smaller than attosecond? I really don't have any idea. What I think attosecond is the, I think they received the Nobel Prize in physics, which is less than attosecond. I really don't have any idea about attosecond. So I have learned physics without my tutor. Great, then you have already achieved the milestone. I assume a Planck time smaller than attosecond, but by how much? That you need to find it out in the internet. I really don't have any idea how much smaller. You need to look into that. Okay, so after answering these questions, let me go back and let me complete what I was supposed to do. So these are required for mathematical modeling, data collection, variable identification, model selection, etc. I've already spoken about logical fallacy. So attosecond, you can just type it, Rudra. I think you can just type what is the unit for attosecond, and you will get to know about that. Okay, another thing which I want to just before conclusion, I want to make sure that what is the difference between thinking and critical thinking. The first is that thinking is spontaneous while critical thinking is deliberate. Yes, most of the time you see whatever comes in our mind is basically a thinking. Thinking is very spontaneous. Whenever we are doing anything, it is thinking. Critical thinking is something which is very deliberate. That means it is, as I told you, it is a deliberate effort, and it is something which requires a discipline. Also, thinking is often based on intuition and emotion. From thinking, we write poems, prose, poetries, anything. But critical thinking is very much which is based on logic and reason. Thinking can also be used to solve problems, but yes, this is the difference. Critical thinking is essential to make good decisions. And why good decisions? Because right at the beginning, if you see my earlier lecture, I've already told that critical thinking itself means judgment. So when we are making a judgment, then definitely we have to make a very good decision. How to develop critical thinking? This is a few points. You need to question your assumptions. I will tell you the story of Amol Kumar Chaudhary. You need to be very skeptical and looking for patterns in the sense you can see a lot of patterns in mathematics, and when you see those patterns, you try to understand that what those patterns actually mean. I'm going to say, how do you realize that you made a logical error? Yeah, if you want to realize that you made a logical error, Rudra, then you have to go through the errors, logical fallacies. I mean to say, this is not the right time to speak on that. There are a lot of logical fallacies that you need to read through, and from there you will yourself understand that which error you have made. So the famous story of Professor Amol Kumar Chaudhary tells that when Professor Amol Kumar, I hope you know, he was a great general theory of relativity, and based on his equation, Stephen Hawking and Roger Penrose framed a lot of things. So Amol Kumar Chaudhary was, when he was interviewed, he was, somebody was asking that, sir, tell me what is the difference between the students in India and students in Cambridge. So Professor Rao Chaudhary told that in here in Calcutta, in India, if you ask a student of, tell the student that Einstein has told this, they would assume that, okay, Albert Einstein, obviously, whatever she has told, that is absolutely fine. But in US or in Cambridge or in other universities abroad, they would say that, is it that Albert Einstein really told? What I'm trying to say, or Professor Chaudhary is trying to say, it is not about the doubt about the talent of Einstein. It is that it is about basically what Einstein was telling, and how you can actually, through what we call critical thinking, find out what Einstein was telling, yes or no, up or down. So it is based basically on the type of, I would say, assumptions that you have. Let me see, let me verify about Einstein's theory. What are the proofs that Einstein told? Can we verify that proof of Albert Einstein, or can we ourselves prove what Einstein told? Then only I will assume that Einstein is right or wrong. So that is basically what is called critical thinking, and that was being cited by Professor Chaudhary. So here are a few of examples which you can take as when you're doing critical thinking. Provide real world applications. Don't take information on authority until you have investigated it yourself. That means not taking anything on face value. Understanding your own biases, that is very important. And we really fail to understand our own biases. Thinking several steps ahead. Yeah, obviously, when it comes to generalization of a theorem, etc., we have to take many steps ahead. Uh, then practice active listening. It is always not being able to critical or finding fault. It is discovering and being adaptive. Linear thinking, yes, I mean to say linear thinking is also important. Willing to change the status quo. That means what I am, I really don't want to be here. And explain like a 5-year old. That is what Feynman's process is, that if you can explain it to a 5-year old child, then possibly you are actually having the best critical thinking mode. So, do you have the potential to think critically? Yes, obviously, you have the potential to think critically, and all these points actually shows that you need to have these things to understand critical thinking. So, please try to challenge the status quo. That means what you are. I mean, I'm not in that state. I want to do better. I want to criticize myself. I want to criticize a theory. I also, it is not being critical does not means that I'm trying to find out a fault. I'm trying to discover and let me being active, adaptive. And also, I need to practice active listening, which is reflective thinking. And I also need to take several steps ahead, because when it comes to physics and mathematics, it is also there. I also need to understand that do I have a bias on myself in order to do so. If I prefer general theory of relativity, for example, myself, then I do have a biasness towards general relativity as a classical theory. So in order to do a critical thinking, I might always think in terms of classical relativistic physics, but I should criticize myself, and I have to get unbiased, and I also have to embrace what is quantum physics, what is quantum field theory, and other branches of science which are, I would say, in contrast with general relativity. Now, this is something which will require another session to talk about how we can come out of our biases. This is not an easy thing to do, because whatever the book we read, the blog that we read, the YouTube videos that we sing, I mean to say, it is actually based on the biasness of a person. Are you getting my point? I mean to say, I am even criticizing myself right in this YouTube live, and I don't mind criticizing myself. I think I am brave enough to criticize myself. So if you are reading a book or you are watching something, then when you make a kind of a decision or of theoretical importance, please be remembered that you are also biased. And in order to come off the bias, you really need a courage, critical thinking, adaptive technologies, and everything else. So that's all for today's, I would say, lecture that I just wanted to tell you. It is not an easy thing to do. Most importantly, how you can come out of your own biases, because either way or other, we are all biased. Whatever ideas, whatever theories, whatever, I would say, belief system that I'm going to communicate to the scientific community is basically based on my own bias. 2 years ago, I have made more curious in reading, learning physics, but now I have less curiosity on physics because my mobile phone and my surrounding friends. How can I overcome from it? I think I have already answered your question. So now it is a question of your study, self introspection, etc. But now I have less curiosity because my mobile phone and my surrounding friends. I don't know. I maybe you're getting too much distracted. That is why we trust our teachers. That is why we do not question. No, it is not a question of trusting your teachers, Rudra. What I'm trying to tell it is that definitely there is a question of trust, but there is a question of introspection. Now, if my teacher says that something E is equal to mc square, I will definitely assume that, but I will always go ahead and try to see what is the equation and what is the derivation that actually showed E equal to mc square. Now, when I'm doing that, Rudra, it is not that I'm not trusting my teacher. It is not that there is a question of mistrust. What I'm trying to say is that what I'm willing to do is that I'm going to further see and be clear that how that formula actually came in. I'm not mistrusting anybody. So that is a very subtle difference. Also willing to admit I am wrong. Yes, absolutely. That is very true. Atharv Kadav is telling, sir, in what ways to encourage critical thinking in group discussions or collaborative project? This is a very difficult task, Atharv, to do because most of us are always doing thinking and not critical thinking. Critical thinking actually in discussions, it won't come because most of the time when you're discussing anything, it is on a very casual nature. It is always on a note that either we are discussing on a very superficial level. I'm not talking that you're discussing about food or movies, but even if you're talking of physics or any theory, it is on a very casual level. Say, for example, say, for example, Mishu Kaku has told, or whatever Brian Greene has told, or whatever just now what somebody told, attoseconds, new discoveries in Nobel Prize. So we do all these things on a very surface level. In order to induce what you call critical thinking in a particular group, what you need to do is that you need to get through a problem. a mathematical statement, a premise, or a typical problem in real analysis, and then you have to create a group, and then you have to try to prove that theorem. Now, when you're trying to prove that theorem, prove that theorem, then comes the critical thinking. So Atharvi is doing something, Rudra is doing something, I am doing something, and together we engage into a discussion of a critical thinking. Then when we finally draw a conclusion in order to prove or in order to analyze that kind of a statement, then we see whose critical power is better, or what are the nuances that has happened, or why this person's critical objective has not been founded. So in order to do a kind of a critical thinking, either you have to take a real kind of a problem, either in real analysis, topology, etc., or the best thing that you can do, Rudra, Atharv, is that you can get into philosophical statement, logical problems, logical fallacies, which my wife is very good at. So you need to go to the 19 rules of logic, the copy statement, and then you take up a statement, any kind of a philosophical or logical statement, and try to prove that statement. The moment you try to prove that statement, Atharv, you are doing critical thinking, because you are doing adaptive learning, you're active listening, you're doubting the assumptions, and whatever we talked in these last two things, then it is the only time that you could do critical thinking. So either it has to be a mathematical statement, premise, proof, or it has to be a logical statement, any kind of a logical issues, philosophical issues, then only you can make critical thinking. Otherwise, do you think that you and me are talking over WhatsApp and anything, critical thinking will come? Nothing is going to come. It is all thinking, and that is why I told you it is very important to distinguish between thinking and critical thinking. Every time we are doing a thinking, only consciously we can do a critical thinking. It is very natural to do a lot of thinking. Sir, I want more scientists' biography videos from your channel. Yes, I will try to make that in short, because to be very honest with you, have seen that biographical videos really don't run well. People don't want to see biographical videos. At least my channel is concerned. They are more into, I would say, physics, real mathematics, real physics, etc. I try to make several videos on Meghnad Shah, Satyan Bose, on the birthday of Isaac Newton, Maryam Mirza Khani, but has unfortunately it didn't go well. But anyway, uh, that is one thing. Sir, I don't know how to teach physics or maths concepts to others, but I don't understand the concept very well. Okay. So you need to work on that. Why theories have to be falsifiable? I would say theories not always have to be falsified until we find another theory which is better than that. And it is not falsifying a theory. Again, Karan, I would like to draw your attention. I have spoken many times. I've made videos on scientific theories also. You can only make the theory extend to another theory. It is not that you may have to make it false. That theory which you have invented or by some other person has got a limitation due to the time, technology, social, economic, political scenario of that specific phase. So if a new theory is being developed, that doesn't mean that that theory is false. That means that theory has got limitations and we are improving that theory. Sir, how can we apply critical thinking in evaluating information and avoiding information? This is a different thing, Atharva. As I've already told, evaluating and avoiding misinformation is something which I told you that when we are reading books, when we are surfing over blogs, when we are watching YouTube videos, we have to be aware about one, two, three, four, five, six things. And if you go to my live section also, okay, hold on, I will just tell you if you have asked this question, it won't take much time because I have not been doing live classes for long. So if I go to my live section, you will find out this particular video, and I request you to go through this and you can find it out more. This is what is how to avoid misinformation and how to get information. Okay, Success Boy is telling scientist biography makes inspiration or motivation for more people. Yeah, I absolutely know Success Boys, and I am also very motivated. I really want to make a lot of videos on different scientists, but somehow the views and people really don't watch it. Maybe you can find out some other channel. I have made one video. If you go to that Karl Schwarzschild letter about Sophie Germain, small videos, but they really don't go well. So you can find out other channels which have got good videos and they really run well. I myself am very interested to make a lot of biographical videos, but unfortunately, yeah. Stone Flower. Okay, if you can let me know your name and from where you're logging in. To develop critical thinking, it helps to be reading at least two books for a course, and the books should be fairly different from one another. That helps getting multiple perspectives. Absolutely, very well agreed, Stone Flower. If what Stone Flower is telling is that if you read two different books, and at least say for example in a week's times or so, so he's telling that if the concepts are fairly different, then you can actually make a kind of a critical thinking, and then you can actually. Daniel Kamal from USA. Okay, Daniel, very welcome. So he is absolutely right to the point. So if you're making one thinking and another thinking, then the critical thinking actually improves from one part of the other. And not only that, the assumptions, the adaptive learning, the process of criticizing, unbiased decisions, all these things actually come through critical thinking. Absolutely fine. I think Daniel's statement actually concludes today's session. Thank you, Daniel, for this wonderful advice. And I hope you come more on these live sessions and enrich us with your kind of a understanding. So yes, reading two different books actually makes an understanding. And I myself, I have seen this result, what Daniel is telling. When I am making one video on topology and one video on the life of Isaac Newton, another video on differential geometry, another video on Maxwell's equation, it actually makes a huge amount of difference in my thinking pattern. It improves critical thinking. Thank you, sir, for your guidance. Absolutely welcome. I would like to do more. Athar Gadav is telling, sir, how does emotional intelligence relate to influence critical thinking? This is a very wide subject, very interesting subject. Maybe, Athar, I will like to come live again another day and talk on that, because it's already 10 o'clock, dinner time, going to sleep. Because I wake up a little bit early. So that is emotional intelligence, reported critical thinking, although it doesn't relate to physics or mathematics. But yes, it is a very interesting topic that you have brought up. I would like to talk on that more. Did all physical phenomena have a mathematical equation? Yes, they do have. Yes, all physical phenomena, I mean to say, all physical phenomena can be described in terms of mathematical equations. Yes. What was the state of physics in Vedic times? Oh, wow. That's a very interesting subject. I've been reading a lot of Sanskrit shlokas, which actually interprets polygons. Pythagoras' theorem, I think it is quite okay from Brahma Sutra. So, do you really want me to speak on the Vedic mathematics and the shlokas of Gita, how they have been interpreted into mathematics? If you want, I would disconnect right now. Please put it up in the comment box. I've got a lot of resources which I can talk, but again, remember that won't be related to physics and mathematics. I will show you the shlokas of Gita, and I will show you how this, because I have been trained into Sanskrit, as you know, that I will reinterpret those shlokas and tell you the how mathematics, management, decision making powers have been influenced by Brahma Sutra, Narad Sutra, Vedas, Ishavasya Upanishad, uncertainty principle in Ishavasya Upanishad, string theory in one of the shlokas of Ishavasya Upanishad. I can let you know, because my background is basically on that. I've never spoken about my background anywhere, and I don't like to be a little bit more personal on channels and things like that. But yes, once you hear me, possibly you will be able to understand. So do let me put up a comment, because until I get a good comment, I don't feel motivated to do those things. But I already have things. I remember those shlokas, so I will just write it on the Jamboard and explain one by one what are the meanings in English, and thereby how the mathematics from the Vedic shlokas goes into the mathematics. Even to Daniel, who is from USA, if you're interested to know more about the ancient Vedas and mathematics, do let me know. How did you get into mathematics and physics? Are you always good at, or you are struggling? I was struggling just like anything, to be honest with you, Karan. I was never good in mathematics. I don't think still I am very good in mathematics. But anyway, that is again coming to a different stage. I will log in one day and we will talk a lot about general things. But right now I need to log out. So those who wants to know more about Vedic mathematics, especially the shlokas, how they can interpret it, let me know. I can talk a lot about that, because that is, anyway, I don't want to be personal again. Goodbye, take care. I think tomorrow I won't be online. I'm declaring it right now, because I'm working on this topology video, which I would like to show to all of you. And I think again, what Success Boy's problem is that he is unable to. Yeah, as I told you, yeah, it is. All mathematical equations can be interpreted. So what Success Boy's problem is that physics, etc., cannot be visualized. I think I would try to remove that after this video on topology. Uh, Thank you very much. Goodbye. Have a nice day and good night.